Hello there. Today we are looking at how to use angle rules to find missing angles. During this video we will cover complementary angles, supplementary angles, vertical angles, interior angles, exterior angles, alternating interior angles, alternating exterior angles, corresponding angles, and consecutive angles. Angles form when two lines or line segments intersect, when two or more rays share a vertex, and when a line or a line segment or ray touch. Vertical angles are angles that are across from each other. Vertical angles are equal. So in this diagram here we have a line segment crossed by a line, and we have four angles that were formed, 1, 2, 3, and 4. And when we look at these angles, the two that are across from each other, we have 1 and 2 are across from each other, and these angles are equal, and 3 and 4 are across from each other, and these angles are equal. This rule works when you have two intersecting lines or line segments. And it works because when we look at the consecutive angles, or the angles that are supplementary on a line, for instance, when we look at this line segment, two angles on this side of the line segment should equal 180 degrees, and the two angles on this side should equal 180 degrees. So with that logic, we can also go on the other line. These two angles need to equal 180 degrees, and 4 and 2 need to equal 180 degrees. So angle 1 and angle 2 are equal, and angle 3 and angle 4 are equal. So let's review supplementary angles. Supplementary angles are two angles on the same line that equal 180 degrees. So since there are only two angles on this line, when we add those two together, it equals 180 degrees. If there were three angles, they would all equal 180 degrees because the degrees of a straight line is 180. So any segmentation that happens along that line must altogether equal 180 degrees. Complementary angles are when you have a 90 degree or a right angle that is segmented by a ray or a line, and all angles must add up to 90 degrees because it's a right triangle. So if you have complementary angles, both must equal 90 degrees. For the problems in this lesson, you're going to be looking at using parallel lines and their transversal to identify the angles. A reminder that parallel lines are two lines that do not intersect. No matter how long they are, they will never cross each other. A transversal is a line that crosses two or more parallel lines. So this line here going across is our transversal. There are several angles formed by a transversal, 8 to be exact. We have 4 angles formed on the first of the parallel lines and 4 angles formed in the second of the parallel lines. There are a few logistics as far as what we call these groups of angles within this transversal diagram, and the first of it which is interior angles. So interior angles are the angles that live between the two parallel lines. So in this case, our interior angles are 3, 4, 5, and 6. Exterior angles are the angles that are outside the parallel lines. So 1, 2, 7, and 8 in this diagram. So we have internal, inside, and external are on the outside. Now, there are some rules that help us identify these. So if we're given one angle, say we knew angle 7 in degrees, we could figure out all of the rest of the angles by following these rules. Both of the vertical angles using supplementary and complementary, but also looking at our alternating interior and exterior angles. So alternating angles are angles that are equal and they're on the other side of the transversal from the angle given. So in this case, some of our alternating interior angles are 3 and 5. So here's 3. We go to the other side of the transversal and the opposite angle, and that's our alternating interior angle. So they share the line of the transversal, but they're on different parallel lines. So 3 and 5 are equal to each other, and 4 and 6 are equal to each other. Alternating exterior angles, we can look at 1 and 7 are equal to each other because they're outside of the parallel lines and on the opposite sides of the transversal. And then 8 and 2 are equal to each other as well. One more rule that we can use is corresponding angles. So two angles on the same side of the transversal that are not next to each other, one being interior and one being exterior, are equal. So if we look at our past diagram, we can see the angle 3 and 6 are consecutive interior angles, and they are next to each other, but they're both inside the parallel lines, but they're on the same side of the transversal. In this case, those consecutive interior angles must equal 180 degrees. Think of them as being supplementary angles, or similar to supplementary angles, meaning they add up to the same. Now, the same would be true of 7 and 2 on that side of the transversal. So we have consecutive, or exterior angles. So you can see that angle 7 and angle 2 add up to 180 degrees in the same way that they would if the parallel lines were only one line. So in your work in this lesson, you may be asked to find the missing angles in a problem like this, or maybe there'll just be one letter listed or one number and ask you to find that angle. For instance, it might say find angle F. So we can use a few rules here to find it, that we can state to our basics with supplementary angles. So we know that this angle is 110, and a supplementary angle to it is B because they're right next to each other on the same line. And so we know that supplementary angles must equal 180 degrees. So if we take 110 plus B, that must equal 180 degrees. When we subtract 110 from both sides, we get that B equals 70 degrees. Okay. Now we can use our vertical angle rule and find C and D. So according to our vertical angle, the angle that shares our vertices but does not share lines is equal. So angle D is equal to 110 degrees. And we can do the same with our angle B, which equals 70 degrees. The opposite angle from it, from going through the vertices to the other side, when we have two lines crossing, is also equal to 70 degrees. We can now use a number of different rules to find the rest of these angles. But let's start with the consecutive interior angle. So consecutive interior angles are two angles on one side of the vertices that are between the parallel lines. So in this case, angle D and angle F, or angle C and angle E. So angle D and angle F need to equal 180 degrees. We have a similar problem as we did with our supplementary angles. We have 110 degrees for angle D. When we add angle F to it, it should equal 180 degrees. When we subtract 110 from both sides, we get that F equals 70. Now we can do the same process we did for our first set of 4 angles by just going around finding the supplementary and the vertical angles. But I want to show you some other rules applied. So if we look at our corresponding angles, we can see that this angle at 110 degrees and angle E are corresponding, meaning that they are on the same side of the transversal and the same side of each of the parallel lines. So that means that E must equal 110 degrees. And we can check this by verifying that the consecutive interior angles add up to 180 degrees. We can also use our supplementary rule to see if angle E and angle F add up to 180 degrees, and they do. We can also verify with our alternating angles that they are equal as well. So our alternating interior angles D and E should be equal, and C and F should be equal, and they are. Okay, so finding angle G and H should be easy. They are going to be the same as C and D because they're the same angles that are formed. So we can, and we call this corresponding angles as well. We can check our supplementary angles and our vertical angles, and there's all sorts of different ways you can verify or make the decision about the measurement for each of those angles. Hopefully this helps you to see the different ways in which you can find missing angles when working with parallel lines and transversals.